All right. So let's say I had, 3x squared minus 2x plus 7 equals 0. And I want to know how many answers and what kind of answers. So what's the only thing you have to look at? Yeah, b squared minus 4ac. So what's b? Negative 2 squared minus 4 times 3 times 7. So you get 4 minus 84, negative 80. So I'm going to have two complex solutions. I love it. It's not that big of a deal. This kind of tells you, if you had an equation you're trying to solve, the boss tells you, make our profit 18 billion, and this is the equation you get, you can go tell them, no, we can't do it. You don't have to do any work with this. You just check this and you go, oh, it's impossible. We can't make 7i dobros, right? What would a complex dobro look like? I don't even know what a dobro looks like, so I should stop. Yeah?
So there's only like 3 possible answers we can give for that.
Yeah. Either 2 complex, 2 real, or 1 real. Yeah.
Well, actually, just in the book they break the real numbers into.
I know. So if you want to go a little further.
Well, I mean, do you want that, or are you fine with just?
I'm totally fine with real and imaginary, real and complex.
Okay.
That's all I need. The book goes into irrational and rational.
Yeah.
If you get a perfect square, you'll be able to take a square root. The square root won't be there. It won't be irrational. It'll be rational. But who really cares? What's really important is it going to be real or not? Because like I just said, if this is an equation representing how I make my company $18 billion next year, the equation is going to say, you're crazy. Right? There's no real way to do that, boss. Come up with a different goal. Right? That's what the math is telling me. And that's all I would care about is just check. Do I even want to do all the work associated with figuring that out? Let me just look at the discriminant. Nope. Not possible. I'm not going to worry about the equation anymore because I'm in the real world. I can't do that.
But we won't lose points on the test if we say real rational. Or real
No, if you say more that's correct, I'm not going to take points off for that.
But if it's incorrect,
If it's incorrect, you have to go. So here's the answer. Come on. You want to answer that?
Oh, no, I thought you were going to give back to you. I thought you were going to give back to you.
All right. Take a quick look, make sure I did that correctly. Yep. So now we're in review. We can talk about anything 1, 2 from 12.6 up through 13.8. Yeah.
Is this from section 13.8, number 7? It's given us the equation, and it says fx is 1 is January, and 2 is February.
Okay.
I got 2.28, so
You got what now? Sorry.
I got,
You got 0.28.
yeah.
Okay. If that's, I don't know if that's the right answer or not, but if it is, that would be strange.
Yeah, because first I try to find the vertex.
Yep.
And I plugged it in, that's what I got.
So let's see. If we try to do that one, this is 7 and 13.8. Okay. Right. So precipitation, that's a big problem nowadays. We're all in drought everywhere in California. How do I find the month? Okay, yeah, that's right. So X is 1, X is 2 is February. Okay. And of course, is this going to have a max or a min? Just looking at the equation.
Max, a minimum.
It opens up, so it's going to have a min, right? And then thankfully they asked me what's the minimum precipitation. So how do I find that point? Yeah, negative B over twice A. So you get 20 divided by 4. It looks more and more like 7. Is that cool? I think what happened is you did this divided by 2 times this. So you actually ended up multiplying by 0.2. That would give you 0.28. So be real careful about putting this in your calculator. Your calculator knows order operations, which sounds great, but it actually sucks because if you put it in incorrectly, your calculator does what you put in. So if you want to put this in the calculator exactly the way I've written it, so let's kill the negatives. So 2.8 divided by 2 times 0.2 is not good.
It's going to go.
It's going to do 2.8 divided by 2, and it's going to take a 0.2 and put it up here somehow, right? So I have to do this if I want to do that. Or just make this freaking 0.4 and get straight to the point. So be really careful about garbage in, garbage out with your calculator. Yeah.
What about number 1F? The x cubed minus 2 equals 6.
Oh yeah, I love that one. Yeah. All right. So there's probably a reason why I put that problem on here, because how many answers should there be to a problem with the highest power of 3? There should be 3. There's always should be that. The highest power for a polynomial, there should be that many answers to that equation. Now, a few sections back, before we talked about complex numbers, if I gave you this problem, we would have just done what to both sides?
Cube it.
We would have cube rooted. We got like x equals 2. Yeah. At that point, that is the real solution. There are 2 other, and I think at one point in the lecture I did mention there should be 3 answers, and 2 of them we haven't talked about yet. So there are 2 more answers. How the hell do I get the other 2 answers?
Complex number.
But how do I get them? What do I do? So this is the same mistake people make when it's like this, and they tell me the answer is 4. Now the way we take care of this is when you take the square root, what should you do immediately? But it's because if I brought the 16 over and factored, I could see them. So that's the trick. You bring the 8 over. You don't do the cube root first. No, you bring the 8 over. So this is 1F on the. Once you put the 6 and 2 together, you get an 8.
Are there different ones? Because on mine it's x to 3 minus 2 equals 6.
Good. So then bring the 6 over and you get
Oh, so
8.
there is different?
Yeah, I started off there and then I put it together. So if I add 6, I get here.
Oh, okay.
What you should do is subtract 2 and get there. Now how do you factor this?
X minus 2.
X minus 2.
Yeah, x minus 2,
X plus.
x squared,
Yeah, x squared plus 2x.
X plus
4.
plus 4 at the end. In the middle is going to be
2x.
plus, right, opposite sign, right? Oh shit, you know there's going to be cubes on this thing now. You forgot that factoring formula. You want to go back and find it. So here I get the real answer we were able to get directly, right? So from here I get x minus 2 is 0, so x is 2. How do I solve this part of it? The other factor equals 0.
Quadratic Formula.
Good, because I told you the big dude can never factor. So it could be complex, it could be irrational, but earlier we just hadn't even talked about quadratic formula yet, so there was no way to get the other 2 answers, so we just got the nice answer directly. This indirect path gives me all 3 answers. So when I say solve, make sure you get all the answers. I'm trying to give you a hint. Look at the power and make sure you get as many answers as is asked for. So how do I finish this out? X equals
Yes, it is.
negative 2
Plus or minus. And then root
4 minus 4 times A is 1, C is 4, all over twice A. Right, and then you just do that. Is that cool? You guys doing all right? Fireworks went off individually this time. 2 years ago, I wasn't even in town. I was somewhere else watching fireworks when that happened.
Will you finish it?
Yeah, sure. What do you get? You help me out. -2 plus or minus. What do you get inside the radical? 4 minus 16. -12. What can I do with -12 in there? I can make
4 and 3.
good. 12 is 4 times 3. Square root of 4 is 2. Square root of -1 is I, and I got a 3 left inside. Is that cool? Be sure you simplify any radicals anywhere all the way you can. As in this case, I can be careful. Yeah. You factor out 2. I love the way you said it. You can't just cancel that because then that guy escapes now. So you really do factor 2 out, but you can, if you're careful, you can just kill a 2 from every term. Because every term gets divided by 2. So then you end up with -1, give or take, I rad 3.
So problems with the 2, with the -2 is that with an 8 at the bottom with an 8, and with positive 2y is that like a 4i. But everything cancels when you cancel out the other 2. Like in my math lab, that's what it's showing.
Do what now?
So it's
I'm dividing by 2.
plus or minus 4i over 8. So that's power -2. And the 8 cancel out, but the 4 also cancels out with the 8. I didn't understand that part.
This would become this. This would become this if they did it correctly. 8 over 8 is 1. 4 over 8 is 1/2.
So that's the correct way.
That would be, if that's the problem, that's the correct way to do it if you want to do the next step. Break it up.
Just cancel it out. I was kind of confused on that.
Alright. Take a picture of it or send it to me or something. Because if it's telling you that, then we gotta teach my math lab. We're gonna teach some math. I'm always a little worried if they just, humans type this stuff in. So they could type something in incorrectly, just like they could in the back of the book. Some of the answers are wrong. It's a great way for me to catch people just copying the back of the book. But, because I know where all the wrong answers are. Or most of them. Oh, I wanted to show you Wolfram Alpha real quick. How many of you guys have used Wolfram Alpha since the first day when I talked about it a little bit?
Played a little bit.
If you haven't, you're crazy. Just so you know that you are crazy. So now watch. I'm not signed in, so I haven't paid any money or anything, and I could just type in there like 2i minus 5 divided by 3i plus 2. And now watch. So it gives me the answer. If I paid money, I can get a step-by-step solution. Here's the decimal approximation if you want it. If that's not enough digits for you, you can ask it for more digits. This is sort of like what I was talking about. Turn by this much and walk this far out. See, it even positioned in the complex plane. It actually grabs you. Here's the real axis, imaginary axis. You guys with me? So the answer was roughly fewer digits. I can't do fewer, okay. -0.3 plus 1.5i, so -0.3 plus 1.5i, that's why they put the dot right there. You guys with me? A little bit? So the amount of stuff that Wolfram Alpha does, even the stuff you don't understand, it's still kind of like, what the hell, polar coordinates, what the hell is that crap? And maybe a few of you might even Google polar coordinates and see what it is or not. That's pretty much what I'm saying in my head, but it still is neat to kind of see the stuff that you don't even know yet, what you can do with stuff. Get a little taste of it, but you can see the stuff that's familiar. You can see the result. That's what you would get if you did that by hand. Cool? If you pay some money, it'll show you the step-by-step solution. Yeah.
Can you do 4a on the bracket? It's just for refresher. I got the vertex and the Y-intercept and the axis. I just remember how you do the other point.
The other point is the point that comes from symmetry. So once you start to kind of graph things, it kind of comes out. So on that first one, well, the first one or the second one, because the second one's got some more weirdness.
All right, we'll do the second one.
We'll do the second one.
So how do I find the vertex? Yeah, the first step is to find the x piece. So negative b over 2a, so negative 8 over twice 4. So again, negative 1. So what's the y piece of the vertex going to be?
Plug in.
Yeah, plug in negative 1.
So you get 4 plus negative, or 4 minus 8 minus 3. Which I haven't done in my head yet.
Just gonna make it sound like-
So your vertex is negative 1, negative 7. Cool. Make it really easy for me to find the work. Please, dear God, don't put the answer there and then put the work all over the damn place. I'm not going to look that much for it. You want to make it very easy for me to find the work that goes with the problem. Yeah, speaking directly to a few of you guys. That's the worst thing in the world to do. The person grading your test is to make it hard. Yes, I just said this at test. Make it hard to find an answer. Don't make it very easy.
So can I go for my work and draw you an arrow? Follow the trail. Answer. Follow the trail.
Oh, don't try it. How do I get the y-intercept for anything?
X0.
Make it x0, so when I make x0, I get 3. Alright, there's the y-intercept. Axis, symmetry, graph, blah, blah. So the vertex is negative 1, negative 7.
So the axis is negative 1.
The axis is always going to be x equals the x piece, because it's going to be the vertical line that runs through the vertex. Any vertical line has an equation, x equals a number, because it's not allowed to go left and right. X has got to be staying somewhere. So the axis of symmetry will be x equals negative 1. Don't say negative 1. It's a line. The axis is a line. So it should have a line equation describing it. Okay. So to graph this, I haven't found my other point yet, because the other point comes from when I start to graph it.
It's pretty simple to find because you got your y axis.
So my vertex is negative 1, negative 7. 2, 3, 4, 5, 6. Now there's. My y-intercept is 0, negative 3. So I've got to have another point. Here's my axis of symmetry. I got to have another point the same distance away on the other side.
So negative 2, negative 3.
Good. So this point would be negative 2, negative 3. So then I can just end. Oh, that's all I got.
And graph it. It says graph it.
It's pretty good for me.
So my question really was more, how do you find that other point when it's not so nice? So like if your y-axis, I mean, because it seems to me like it's always...
No, even if I gave you one, let's say here's the vertex is at 3, and the y-intercept is at 0.714. That's the only way I can really make it ugly. So then where's the another point going to be? This is 3 away, so the other point's got to be 3 away. So it's going to be 6, comma, 0.714.
So if your axis is crappy.
Oh, yeah, then you'd have to just double or, go twice as far away. It still can't get really close. It still can't. So yeah, if I made this 3.4114, then it would be 3.1, another 3.4144, so 6.2, 6.822a, comma, 0.715. Just got to go the same distance on the other side to get that other point by symmetry. Right? Now, since I don't say another point by symmetry, you actually get another point just by plugging something into the function and getting an output, like you would for a table. But if you get the other point, make sure it's on the other side, because you need to get that whole, turn. You want to see another point over there so you can see how it turns on that side. So by symmetry is the best way to go. Or you can just plug something in and get a point that way. There's nothing wrong with that. Well, review day, it really depends on how long you want to stay total. So we don't necessarily have to take an official break. How much more? So it totally depends on what you want to talk about. So we can stay till 12:15. It's not a problem, and we can talk about every section, whatever you want to do. Yeah.
I got really confused with the word problems in 13.4.
In 13.4. Oh yeah. Okay. So any that we're looking at specifically? So why is this just coming up now? 9 was tough. Okay. So the Hudson River, at a certain time it flows at a rate of 3 miles an hour. A patrol boat travels 60 miles upriver. So that means going against the current. Where'd it go? Number 9, there it is. Travels 60 miles upriver and returns in a total time of 9 hours. Now, let me try to nip this in the bud. Don't do that. Because then, how much total time is it?
18.
So then you go, okay, let me make that 4.5 and make that 4.5, but they're obviously not taking the same amount of time because in one direction they're going faster, right? So what is the same for both legs of this trip?
Distance.
Yeah, both legs they went
60 miles.
60 miles up and 60 miles down.
So the rate downriver would be X. Well, it could be X, and then...
Yeah, so my unknown will be my speed of the boat. Because know how fast the current's going. So if I go upriver against the current, how fast?
X minus 3.
You good. X minus 3. Now if I go downriver,
X.
plus 3.
So it'd be 60 over X minus 3 plus 60 over X plus 3.
So since distance equals rate times time, time is distance over rate. I love it.
Then,
Now don't set these equal to each other.
yeah,
They're a very strange answer.
Add them to equal 9.
Equal to 9.
Good. You add them up and make them 9. So your equation comes from the total time being 9. So it feels like at the beginning there's part of the information you're not using, but you don't use it to create this. You actually use that to make your equation. There must be something they told you that tells you how to make the equation out of it. So you fill in everything you know, and the minute you get 2 of these filled in, the third one you fill in by using the equation. You don't fill it in with more information. All right, so the time, total time, so this time plus that time has to be 9. And we know exactly how to attack that kind of problem. Right? Oh, sure.
Multiply
So what's he missing?
X plus 2.
Oh my God. Graveyard. So let's see, x plus 3, x plus 3,
X minus 3.
x minus 3, x minus 3. And this guy's missing everything. Now once you get everything the same, you can multiply by that bottom, so they all just disappear. And then you get a nice little quadratic equation.
60X is 180.
You do, because I just told you.
It's 180 equals 9x.
9 squared plus 3, and let's see, get out of there. Let's do minus 3 so the middle term cancels, then you get minus 9 times 9 is minus 81. I'm sort of skipping a couple steps, but you guys can FOIL that and then bring a 9 through and you get there. And then the next step is to make everything equal to 0 on one side 11. Because you got a higher power than 1 there, you got to do that. So you, here the 180s cancel, that's nice. I get 120x that I can subtract, so I get 9x squared minus 120x minus 81 equals 0. And before I start doing quadratic that, what is something I could divided.
By 9.
I can't quite divide by 9, but I can divide by 3. I know I can divide by 3 because all the digits 9 and 81 are obviously divisible by 3, and this adds up to be 3. 1, 2, 0.
Right.
So 3 will go in. And you have to add up to 9 for 9 to go in. Do you remember that? That division rule? So then you divide everything by 3. And then you start doing quadratic if that won't factor. Yeah, there's no way that's going to factor.
So plug it in quadratic form.
Quadratic, exactly.
40.
Quadratic. Yeah.
For the same section, number 15 to 24, is that going to be?
24?
Oh, yeah. I didn't put any on there, but it totally could be. The only thing that this adds, you should have done in the past, you should have done stuff like solve this for W. Right? You did. Let me just say it like that. I don't want to get any blanks there. You did something like this in the past. The only new thing this adds in is the possibility of having to take a root to continue. So if I had an equation that was t equals 1/2 RT squared, and I want to solve for t. What's the first thing I could do?
Multiply by 2.
Beautiful. Kill fractions that you have in there so you don't have to look at them. So we multiply by 2.
Divide by R.
Good. Divide by R.
Square root.
So see how that rule, get the variable. Where the variable is, get that piece alone, and then get the actual variable alone. So then what? And then take a square root. It doesn't have to be plus or minus. It's time, but maybe they won't tell you. So put a plus or minus just in case if they don't tell you. You can have negative time. Before the space shuttle lifts off, it's t minus. It's negative time. Yep.
Just kind of going back to that one with the 120, how you did just the addition of numbers to figure out how it's divisible by 3. What is that rule? I've either forgotten it.
About that, do we?
No, we did.
Anything that adds to. Let me see if I can do it in my head. So, what do those numbers all add up to be? 1 plus 2 plus 1 plus 5. So 9 goes into that number. Period. End of story. It's just a property of 9. It's just how 9 kind of works.
So it doesn't matter how big or how small the number is.
Doesn't matter.
They add up to be.
If the digits add up to 9 or a multiple of 9, like they added up to 18.
Right. So
if I had 1, 2, 9, 1, 5, those add up to 18. 9 will go into it. So will 3, because 3 has the same rule. If it adds up to 3 or a multiple of 3, 3 goes into it.
Okay.
So it's easier for 3 to go into something than 9. It makes sense, right?
Is that for any number, or is that only for 3? The 9?
No. Yeah, that rule is specifically for 3 and 9. 2 goes into an even number. You all know that. 4 goes into any number where the last 2 digits are divisible by 4. So if I had this number here,
Yeah.
I can't believe we never. Yeah, I guess not. We didn't talk. So you guys have never heard it. It's really funny to me. What's 9 times 5?
45.
What's 4 plus 5? 9. What's 9 times 9? 81. What's 8 plus 1? 9. Crazy. It just really makes me sad almost that nowadays in high school and stuff they don't teach that kind of stuff because they suck. Any number where the last 2 digits are divisible by 4, the whole damn thing is divisible by 4.
What's the rule for 6?
Real quick. The reason 4 works is because 4 goes into 100. I'm going to let you think about it. If 4 goes into 100, it'll go into anything where the last 2 digits are divisible by 4.
And the powers of 100.
Yeah, because the first part is just so many multiples of 100, and it goes in. So as long as the last 2 digits of 4 goes into it, it goes into the whole damn thing. Good little rule to know. 6, it's got to be even, and it's got to add into some multiple of 3. Right? It's got to be divisible by 2 and 3 for 6. Does it make sense?
Yeah, I just couldn't remember it.
Okay.
It's been a while.
So,
7
are there
does
rules
not
on
have a
this for
rule.
everything?
Or level
What's the name
7.
for this?
Divisor rules.
Divisor rules.
Yes. You're trying to divide by 3. 3 is the divisor, so the divisor rules.
Yeah, number.
That's enough of that.
Oh,
Sorry.
number 56, the same section.
Was that good enough, by the way? I don't know. No. Did you want what? We can go over it right now. It's fine. And then I'll come back to you. Okay? Are you looking at any specific ones that are freaky?
Like number 18.
18? Oh yeah. So remember, we did these kind. So the first thing I mean, you're trying to solve for k. Right, 4. What really sucks about trying to solve for k here is how many terms have k in it, and can you put them together? So you can't solve directly for k. If that wasn't there, I could multiply by 2, divide by -2. I can solve directly for k. If I can't combine them, I cannot solve directly for it. So I'm going to eventually have to use a quadratic formula. That's like the one we did the other day with the big D squared, 2DH. Remember that the one we did group work? That's what again. So I first have to double, right, to kill that, and then add the 2n over, subtract it over. Bless you. Then I can see what my a is, my b, and my c, negative 2n. Just throw it into the quadratic. Yeah.
Alright, now I have to multiply by.
See it?
Seems like the first step that you do is multiply each side.
Good. Whenever I have a fraction in there, the first thing I do is just kill it. Get the fraction out of the way. Right? Because then that frees up everything else to kind of move around and do stuff. So to do one more step here, a is 1, b is -3, c is -2n. So the quadratic formula doesn't care if you're throwing into it 1 or 3 or n's or 2hd. It doesn't care. Just throw it in. So then k, negative b, so 3, plus or minus b squared, minus 4 times a times c, all over twice a. So I get k is 3, give or take, square root of 9 plus 8n. Can I do anything with this square root? Good. Don't tell me square root of 9 is 3. I don't care. I don't have a 9. I have a 9 plus 8n. I can't do anything with that. Nothing comes out like you did with the 4 that came out of the big D problem. Nothing comes out. I'm done. I solve for k. What I hate is when students, I see people that'll multiply by 2 and then add the 3k over and then take a square root and they say, there, I solved for k. What's wrong with that? There's a k there. There's a k there. You didn't solve for k. You didn't get k by itself on one side. There's a k right there. So that's not the right way to go. Whenever your variables have different powers on them, so they're not like terms, you've got to have some other way to do it.
Okay.
Oh yeah, sorry.
Yeah. Number 56, the same section.
Oh, the special relativity. Oh, it kicks ass. I really just wanted to assign this to you to, well, I want you to solve it, but I also want you to realize this is true. The faster you go, the heavier you get, believe it or not. So if you go really fast, speed of light, you become infinitely heavy. So think about that. Why haven't we made a spaceship that can go the speed of light? Because the faster that spaceship goes, the heavier it gets, the harder it would be to keep that momentum up.
It's only based on mass.
Mass, exactly.
That's because the mass, the equivalency of the plane is in Earth. So if you're able to change your mass dimension against the plane, then you're able to overcome that.
Could be. I think this is what they. All right. I'll have to take your word for it in a moment. So they ask you to solve for C. This is in the synthesis section. This is definitely a bonus problem, right? Because this thing is really, really, really disgusting.
So you multiply by its conjugate.
Clue I'll give you is you get these together first. Believe it or not. And then this is the real bonus part of this is it looks disgusting. It's actually really simple. I know you guys don't believe me, sorry.
Okay, so it's 1.
How do you get these together?
We'll get a common denominator.
Good. What's that going to be?
It's going to be c squared.
Good. So you get c squared
minus v squared.
c squared minus v squared over
C squared.
Good.
Square root becomes c minus v over c.
Careful. I can't square root these parts of a subtraction problem. Right?
Why not? Because they're all.
I don't care. Square root. Can you do the square root of what do you got, Jeff? 23? Or let's make it even better.
Yeah, but since both of those are squares, why can't you?
No. Can you do the square root of 21?
No, but you can.
Well, can you suddenly do the square root of 25 minus 4? Roots do not play well with subtraction because roots are based on multiplication. I can't distribute a root through to each piece.
Okay, then, okay.
Okay. So no.
C squared minus v over c. So multiply c by c, or?
Well, you can multiply by the reciprocal to kind of turn this thing over. I have a complex fraction here. You guys just let this in. There's a few different ways to do this. Let me see. I'm not going to spend a ton of time on this. I've already spent more than I want to. But if I multiply by the reciprocal, then that's one way to make this not complex anymore. We've done complex fractions before, right? So I could actually look at it as multiply the top by c, multiply the bottom by c. So then I don't have a complex fraction anymore. I got CMO over square root of c squared minus v squared.
And we're still trying to find c, huh?
Good. And so you can multiply this up. Square both sides to kill the square root. Get all your c stuff together. All right. Since you guys are actually interested, I'm not going to stop here. So I multiply this up. And I can divide the m down also. Is that cool? See how those just switch?
Right.
And then I can
Square.
I have to because my c is in there, right? It's in two places. I got to worry about that in a minute. But if I square right now,
C squared minus, or c minus v.
that cancels there. So square all those. Is that cool? Because I had to square both sides, so I squared all that stuff.
Let's multiply by m squared.
Beautiful. Multiply by m squared. Kill the fraction like we always do, right? So multiply by m squared. So I end up with m squared c squared minus m squared v squared equals c squared m0 squared. I'm not squared.
Can we get c squared to each side, or to the same side?
Yeah, you're trying to solve for c, so you want to get all your c stuff together, so you want to add this over and subtract that over.
M squareds cancel each other, don't they?
No.
Oh wait, yeah, it's multiplication.
Right, so subtract that over, add that over, get all your c stuff together. What can come out of here now?
C squared.
C squared.
M squared minus m squared.
Oops, I'm not going to get that. And then to solve for c squared, I can divide by that, and then I can square root to get c by itself. Yeah.
And that was easy?
Huh?
And that was easy?
Yeah, it only took one board. What are you talking about? Yeah, I'm taking classes where the teacher basically starts on that side of the room. And I'm not joking, ends up like halfway down that side. So that's one problem, and he goes, very simple, very simple. Next problem. Somebody erase the boards. Okay. Yeah, he had us working the whole way.
Wait, do we need to get it done?
Is that later now?
What's that? Don't worry. Don't worry. Yeah, that's not going to happen to you yet.
So,
And then you'll forget it anyhow, so whatever.
Aw.
so I've got one question on,
Yes.
In the
Oh.
same section, in 39, I just want to set up this equation. I'm having issues.
The one with LeBron James?
Yeah.
Let's see how far he leaps out of Miami, but we'll see. Report has a vertical leap of 44 inches. What is his hang time? So use vertical leap V equals 48 times time squared. So where would you put the 44 into that equation? In place of V, because it's a vertical leap. So now you're trying to solve for T. Divide it, and then square root it. And you know you can take the positive part, because we're talking about just real time, yeah. Yes, sir.
2B on the practice test. I was kind of curious, but I just want confirmation on the answer. Because I got all the way up to the IRAD 39 over 2RAD 5 portion. I'm guessing we just don't want radicals on the denominator.
Especially, yeah, in general, it's just like reducing a fraction at the end of the problem. If you have a radical on the bottom, you rationalize it. It's just part of what we do. If you didn't do that, I wouldn't kill you. But one big reason I want to do it there is so I can compare it to the answer I get when I do it using quadratic formula. I can compare.
Because I didn't do the rationalize the denominator.
All right.
I was wondering if that's what you want us to do always.
Yes. Because when you get into pre-calc, they're going to expect you to do that everywhere. It's just like getting 6 over 8 as an answer. It's not good.
But even though it's 2RAD 5, you don't worry about the outside numbers?
They're already rational. I just worry about the irrational part. Yeah.
67 on 13.3.
Which, I'm sorry?
67, 13.3.
13.3. Who are they? C jumps right at you. Hopefully I can say that. This problem gives you a parabola graph and it says find the equation given the graph. It gives you 3 points. So can you see what C is? When x is 0, I'm at the y-intercept. And what's the y-intercept? Yeah, so C must be -3. So there's a gimme. And then it gives you basically the 2 intercepts. There's 2 ways to do this problem. There's the quick and easy way, because this comes out to be really nice. Let me show you the slightly harder way, because it works for more complicated problems. I don't know why they made this a bonus. It's not that hard. But if I know the equation of a parabola is this, how many unknowns are there? Truly unknowns. X is a variable. It's not really unknown. I plug stuff in. So how many unknowns are there? 3. So how many relationships, how much information must I give you? 3 pieces of information. And they do that. They tell me if x is 0, so if I look at ax squared plus bx plus c, if x is 0, a times 0 squared plus b times 0 plus c is -3. Plugging a point in, right? Yeah. Then at the point, there's another point, the 2 x-intercepts. The point 1, 0 and -3, 0. So 1, 0. What does that mean? That means that a times 1 squared plus b times 1 plus c. But c, we know c is -3. Has got to equal 0, right? Plugging a 1 in for x and a 0 in for y. So those points are actually pieces of information that I can set up an equation for. I've got 3 of them because I have 3 unknowns. And then the last one, -3, 0. So a times -3 squared plus b times -3 minus 3 must be 0. So then you have 2 equations. Because this first one really just gave you c, right? 2 equations, 2 unknowns.
And then you can solve
Elimination, substitution. Yeah. The funny thing is, considering that these are the x-intercepts, where would those come from?
graphing points.
Where would this 1, 0 come from? What would it look like? Yes. Where would -3, 0?
X plus 3.
If you multiply the x squared plus 2x minus 3, what's this guy's y-intercept? So that's the answer. Done. That's why it's not really a synthesis
So all it
problem.
was asking was the Y-intercept?
What's that?
So all it was asking was the Y-intercept?
No. I know the intercepts, and that's the basic equation they would come from. The Y-intercept is -3. I'm done.
Right, no, that's, I don't know which question we're going through, I'm just.
But they're asking me for find the equation, find the values of A, B, and C.
Full equation. Oh, okay.
Yeah. In general, you have to do this. But here specifically, they gave me too easy. I can write where that came from, and it happens that if they would have told me the Y-intercept was -6, I would have just doubled this. Wouldn't that make -6 there? That's bonus. I'm not worried that you're all looking at me like I'm crazy. It's bonus. Who cares? So that's all I'm going to say about it. Yes?
And another question. Number 21.
Where?
865. Page 8.
Oh, page 865. Number 21. Oh. So this is one like we did earlier, but this time they say, what's the maximum product of two numbers that add to -10? So how do you write that they add to -10? How do you write that? As an equation.
X plus Y.
Yeah.
-10.
Some unknown number plus some unknown number equals -10. And then how do I write the product?
X times Y.
X times Y. Cool. And then you solve that one for Y or whatever you want to plug it into the other one. Yeah.
Number 10, this product. The question.
Yeah, so if you solve for X, then you can solve for Y, you'll know the two numbers. Because the two numbers are X and Y. If I figure out what X is, then I just plug it in here to figure out what Y is. And that will be the two numbers that make this happen. Yeah, make the maximum product. Yes, sir.
3D on the practice test, with the answer being -18 plus 4i.
Where are we at? Sorry, 3D?
3D. The answer of -18 plus 4i. So you could pull a 2 out of that. Do you want us to do that or not? And if so, why?
Yeah, that would be my question. Why would you do it?
I don't know.
What does a complex number look like? What's a general form of a complex number?
plus bi.
A plus bi. If I have two complex numbers that are divided, multiply, whatever, the answer is going to come out to be a complex number. It has to be in that form. Factoring a 2 out takes it out of that form, so don't do it. Yeah. I would only do that if there was over something where 2 also comes out. I can kill the 2's. Here, there's no other step.
Okay.
So I want to make it in that form, yeah. Good. Yes?
Last question.
Sure.
Okay. Number 15. Page 864.
15? Oh, yes. That's my favorite. Economite Plastics plans to produce a one-compartment vertical, blah, 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 blah. All right, so this is, if you go into pre-calculus, you're going to want to pay attention to this. This is like the favorite problem in pre-calculus. Making a gutter, you take like a long metal sheet and you bend it. And should you make it a trapezoid or a square or a rectangle, what would be the maximum area? Because you want to catch as much water and breeze as you can in that gutter. You with me? In that, whatever they call it.
Which?
You with me? A little bit? Not at all?
Which one is this?
Number 15 in section 13.8. So we start with a 8-inch by 14-inch plate of metal. And then they fold it. Bend the long sides. All right, so they fold it like this. So if I look at straight on, it ends up like that. You with me? Mm-hmm. So let me try to draw this. This could get scary. All right, that's not too bad. Okay. I can deal with it. It should be open there, Jeff. There you go. Yay! That's horrible. All right. So I bent it like this. So how long is this? 14, good, because that didn't change. But how long is this?
We don't know.
We don't know. Good. How much did I bend it up by? That's really, so here I'm going to pick some amount to bend it up the same amount. And of course, each of these bendings are going to be how long?
The same.
The same. So how long are they?
X.
Good, because I don't know what the hell it is. Okay, sort of with me so far. So anytime you do a problem that you bend the sides or you cut out the corners, they like to cut out the corners and then fold those up and make a pizza box or something. If you cut out the corners of this, cut those out, then you can fold it in and make a pizza box, right, or something. You kind of with me? And then this would be, how much did you cut out? You'd say you cut out X. Because you don't know how much you cut out, right? So here, I don't know how much it bent by. They didn't tell me, so they're X. So how long is this?
Y.
Not really. How long was it before?
8 minus 2x.
8 minus the 2x's that you folded away.
Okay.
Craziness. So the first step of this problem is to fully label the picture that they gave you. They sort of labeled it. They gave you a little hint. They said, this is X. I would go back to the original and say, oh, that's X there, so that must be X there. They folded it up by the same amount on both sides. And that kind of helps you figure out, well, how much is left to actually be here. 8 minus those 2 x's that you folded away. Beautiful. How have we done so far? And then they ask, all right, how tall should the file be in order to maximize the volume? So how much volume can this thing hold? How do you figure out the volume of some let's try something. How do you figure out the volume of this?
Cube. Length times width times.
Length times width times height, right? So it'll be length times, where you say length times width times height. Multiply all that out, you get a parabola. You can do the negative b over 2a thing to it.
So, and with that, it wouldn't matter whether you did 14 first or the aggregate distribution, right?
Doesn't really matter, no. You could bring that out here and make it 14x and bring 14x through so you don't forget anybody. Oh, yeah. And you got the answer key, right?
Oh, no. It's an answer.
And you got the practice test, though, right?
Yeah.
Okay. So that problem, it doesn't directly fit into the ask me, tell me thing, because right there, it's almost too easy. You could write a y there, and the volume would be 14 times y times x, and then have y would be 8 minus 2. But it's just easier just to put it all. You know this is 8, so what's left? 8 minus 2x. So yeah, it's actually a little more direct. We get right to they ask me the volume. And then I can just multiply it through and get the negative b over 2a. Right? Is that cool? Do you guys see how that goes?
For the
So
height,
it'd be 112x.
it'd be over 2a,
Say again?
because it's asking how tall, so it'd be the height.
Minus 20x squared.
Good, because x is the height. So once you solve for x, you're done. Because that's all they ask for, is the... Oh, and how tall should it be in order to maximize... Well, yeah, that's all they ask for. It's how tall it should be. So your negative b over 2a, and you're done. Sweet.
There's a lot to stick to that. It seems like
Thank God this is not the only thing mathematicians do all day. How do we create a really good file folder? Let me set it up then. Oh, God, that's not what math necessarily is. Yeah.
Number 72 on 13.3.
Oh yeah, what are the answers? Can anybody tell me what the answers to this would be? What are they? What are the answers to this? Oh man, everything was. Sure. almost an evil question because it's so. We started here to create the quadratic formula. The quadratic formula are the answers to this. So this x equals negative b, that's the answers to this. So what they're asking you to do is take the plus, add it to the negative b minus, and see what you get.
Yeah.
It's kind of, you'll see what's happening, plus this over 2a, minus this over 2a, those parts go away. That's why it comes out so nice in the end. It's an interesting little side note.
So what?
So the question is, show that the sum of the solutions to this
Yeah, that.
makes negative b over a.
I remember it now.
Sounded like you did. Strong emotions on that problem. Poor little problem.
So I've got a question on number 5 on the practice test.
Mm-hmm.
You never put what type of
I know.
you want.
I know. So if somebody would have made a semicircle on that, I would have been happy. So
got
yeah,
more
I'll say a
area
rectangular
that way.
play area. I'll say that on the test. But number 5, you have to assume that I mean a rectangular play area.
Well, we didn't.
Cool. I like it.
Max area is a circle.
I mean, it's yeah, if you have a semicircular area there, because they say using the back wall of your house is one side, so that kind of is a giveaway that it's going to be rectangular, so you have a side. But you talk about the diameter being along there, right? This is 36, that'll be your half of your diameter, so it's like pi r.
Yeah, that's what we did.
I like it.
And
That's sort of how you
down.
prove what I was talking about earlier about the circle being holding more area than the
the
square.
radius of 11.465 feet. Which
Kick ass,
come
man.
out to be
So if I would have asked exactly that question and you would have done that work, I probably would have given you +1. Kicks ass. But I will say on the test, I will say a rectangular play area.
Okay.
Yeah.
In extra credit, there's a number 25, page 834.
25?
Yeah.
Oh, so,
Something to do with the rad messing.
well, the funny thing about this is one reason why I made this extra credit is because this is an example of a problem you don't have to use quadratic formula on.
Oh, really?
But you have to if you're going to do this bonus, because that's the way they want you to do it, right?
Oh, okay.
Because you can just solve for rad r and then square both sides,
Right,
right?
right.
But they want you to look at this as, this is r minus twice r to the, what power is this to? Square root is a what power?
Second.
No, that's the square. What's the square root? 1/2. And the only reason I'm doing that is, can you check to make sure this is in quadratic and form? Is that half of this? It's a 1 there, yes. So it is quadratic in form. So when I go to do the quadratic formula, I'll say square root of r is negative b plus or minus. So the last step I have to do is square both sides. Since it's a radical equation, you do have to go back and check both your answers.
The end said it was just, what's it called? It was like a plus or minus rad 7, I think. Let me check.
Okay.
But I didn't get anything around there.
So negative b, what's b?
Negative b is 2.
Good. So negative 2 is 2, give or take. B squared minus 4 times 1 times negative 6.
Yep.
All over twice a, so you get 2, give or take. 4 plus 24,
28.
over 2.
And 1 plus or minus rad, or 2 rad 7.
So the 2's all canceled. That's equal to square root of r.
1. Oh, 1. I keep forgetting.
So then you have to square both sides.
So it's 1 plus 2 rad 7.
So 1 plus rad 7 squared, and r equals 1 minus rad 7 squared.
Why minus?
What do you mean?
That makes sense.
It's plus or minus.
Oh.
So if you're going to square both sides, you got to square both of these numbers. You might as well do it one at a time to keep track of what's going on.
7. All right, that makes sense now. Equals 8 plus or minus 2. Thank you.
Sure. Yep.
Question 8 on the practice test. Actually, it was a banging some page number or something.
Yes.
Something like that. But anyways, the exact answer of d equals the square root of 10 rad 600. You can simplify that to 10 rad 106. Would you accept that as well?
Yeah, I love it. Sure. Yeah. You can take the square root of 100 factor or make it 10 out front. I love it. Yes. I think at that point I was just like, get done. Cool. So be really careful because on the test I might ask you, give me the exact answer and an approximation. Exact answer would be
The 10 rad 106.
yes, with the radical still in there. Because anything else you give me decimal wise is going to be an approximation because you got to stop somewhere and it wants to keep going forever. Cool. So when you get to pre-calc, your teacher might say, give exact answers only, and students think 1.5793229 is exact. That's exact. No, you had to stop somewhere. That's why it's not exact. You know, so rad 10 is much more exact than 3.1 blah blah blah. Because rad 10 is exactly it. Right? Yeah.
Can we turn in the handout questions on that?
Yeah, sure.
I got stuck on number 12 of 13.4. It's another word problem.
Oh, okay. So it's the form of the equation with 1 over 1 plus 1 over the other one equals 1 over both, right?
That's what I was thinking. I just didn't know how to write it out.
So what do you know for sure? You know that together they can fill the tank in 2 hours. Got it. So together goes here. Together they can fill it 1 tank in 2 hours. Now here is going to go how long it takes each of them alone
So the large can do it 3 hours less.
than the smaller.
Small.
So if we call this small and we call this one large, the larger one does it in 3 hours less than the smaller one.
X and X minus 3.
Good. Small is X, and the larger one is 3 less than that. And then solve.
I was thinking of, for some reason, doing it with rate times time equals distance.
No.
I don't know why.
It actually is loosely based on that. It's more like an amount equals the rate times time.
Okay.
Because, I mean, if I could type 40 words per minute, that's a rate.
Right.
Times the time would be an amount of words total, right? So D equals RT is actually a more specific from a subset, but we just jump straight to this because it makes so much physical sense. To me, it does. Together, they can do this, yeah.
So homework-wise, it needs to be turned in. This test is up to what, 13?
13.8. Yep. Oh boy. So just remember, if you can't get every single thing done, just do what you can to get ready for the test. It's number 1 priority.
AKA do the homework.
Huh?
It's AKA do the homework.
Do as much as you can by tomorrow.
So if we do a practice test, we should be good.
Yeah, if you didn't have any real trouble with stuff on the practice test, you should be ready for the test.
Like no surprises.
I don't know how you mean. So,
I mean, like pretty much everything on the practice test. If we do it and study it, perfect it, we should do good on
be real careful. Remember what I said about practice test. Don't do the problems like more than a couple times because then you start becoming really an expert at that specific problem.
Okay.
I'm not going to give you that specific problem. Yeah. So just do it at most a couple times, and if you still have trouble on something, go find that section and try some odd ones out so you can check the answer in the back or something. Yep.
I'm lost with what you said.
What's up?
Like, that means I have to, I don't understand.
Since you're here,
Mm-hmm.
in order to knock yourself down to not pass, you'd have to get less than this averaged on everything left.
Oh, okay.
So this is what you need to average on the next test, the next quiz, the final. If you average this or more, you'll pass if you have all the homework turned in.
Okay.
If you had none of the homework turned in, you have to average at least this on everything left to pass. Does that make sense? Cool.
Can I still turn that in or no?
Yeah, please do. Yeah.
Okay.
So you can turn in chapter 1 homework on the day of the final. It'll be very late, but you'll get more than 0 for it.
Okay.
Yep.
So we have 1 plus 13. So this is 0. And we will turn to 3, 4,
I turned in about a week ago on the